2020. So question 1. I used the CAS for this. I defined f of x is equal to this. Then I found f dash x equal to 0. Then I let x equal to 0 and then solve for a using the CAS. So I just found that a equals 6/5. For question 2, we know that the range is going to be from 0 to pi, and we know that because we're doing a mod, it can't be negative. So I just let y plus a over b is greater than 0 and smaller than pi. And since it's greater than it's a mod function, so it has to be greater than 0, we cancel out a, and it's going to be b pi minus a. So it's going to be option B. Question 3 is going to be is train and the velocity. Yep. So it's from 230 to 260. We're trying to find the function. So I did v minus 0 over t minus 260, and we know v equals 10, and it starts from 0 and it ends with 230 minus 260. Yep. And then we find the function, which is v equals 1/3 260 minus t, which corresponds to a and d. And because at the start it's 10, it's v equals 10, and it takes 30 seconds, so v equals 1/3 t, not 3t, so option A. And question number 4, so we just put g of x into f of x, substituted for x, and I got this. And we know that cosec squared x minus 1 equals cot squared x. So root of cot squared x is just cot x, or we can just skip a step and make it cos x over sine x. And cosec squared of x is equal to sine squared of x. So then this just cancels. So then you get sine x cos x, which is equal to half sine 2x. So just going off ABCD, we can just see that it's E. Question 5, let this, given that the complex number z equals a plus bi, so 4a squared plus b squared over 4a squared equals to 1. b over a, so b over a, b corresponds to imaginary, which is lm z. I just use the CAS to find this. I just subbed in z is equal to a plus bi into here, and it gave me this. So then if you simplify it should equal to this, and then that's going to be 1 plus lm real squared, which is a. 6. With the rule p of -2 equals 0, p of that, you just sub in like this for here using your CAS, and you sub in this one as well, and then you should get a, b, and c. Should get to z minus 3i and z plus 3i using the conjugate. So z plus 2 minus 3. So it should be negative. So it should be 2. 3 times 3, 9. And then 9 times 2, 18. Yep. Using the CAS, I just found that it was these values that corresponded to A, B, and C. Seven. So 1 over ax. 1 over ax, x squared plus b. I just used the CAS again. And I think it was to prop frac or something like that. On the CAS. I think it's under transformations or action, I think. And you can sub in a value for A and B if it doesn't work, and then look for which one it would equal to. But it should equal to A over x plus b over x plus mod root b plus c over x minus mod root of x, no, b. So that corresponds to D. Given that x plus iy to the power 14, find all values of x. So x plus iy is going to equal to negative I x plus yi to the power 14 is equal to I to the power 14 x plus yi, which is equal to negative 1 x plus iy 14, which is going to be negative a negative bi, which is option A. Question 9, so xy is a point on the curve, the x-intercept on the tangent, so xy is equal to the y value of p. So the x-intercept is a point on the curve in the x-axis is equal to the y value of p. So I looked at each of the curves and I found the gradient for which there's gonna be none at like here at these values. So that would be like here, this one corresponds to this one. This one didn't make really sense. And to the y value of p. And I found that the one that made the most sense, so this one wouldn't make sense because it has to be all the way at the x-axis. So I think it was B. Yep. Question 10. With 300 grams, it is over in 50 liters. So 300 15, so 300 grams, 50 liters, 15 grams at 2, so 15 times 2, 30, minus kept stirred at the same time 5 liters, so 5 liters flows out. So something times 5, so we don't know this value, so M, we'll name that as M. And we started with 50 liters, so 50, and since it's going into out, poured into the tank at a rate of 2 liters per minute, and at the same time it's going out 5. So then 5 minus 2, so negative. So it's going to be net out 3. So then that's going to be minus 3t. So then that corresponds to D. 11. So we have to somehow, we can cross out this one already, because since this is according to X, but we're finding according to U. So we're trying to cancel this top bit, and the only way we can do that if we let, the only way that corresponds to sec is like tan. So if we're going to diff something that equals to sec, we have to diff tan. So we let U equals to tan x du dx sec squared x. So then if we do dx du, it's going to be 1 over sec squared, and that's going to cancel out with this one. And since we know that U, so then it's going to be 1 over sec squared. We can use this, tan squared plus 1 equals sec squared x. So then you can use the calculator to like simplify it. So then you can find that U squared minus 3U plus 2. And then you can put this into your CAS and convert it to partial fractions. There's a function, I think it's like fraction under action or something like that. Otherwise it's just going to be 1 over, you can do it by hand as well, U minus 1. And since it's going to be like tan, so tan of pi by 3 is root 3. So this is going to be out. So 1 to root 3. And U minus 2 minus U. So it's going to be C. So question 12. dy step size is going to be 0.1. So the initial is E, so E plus step size, so H, the formula is like H times F dash X, so dy dx. So E plus 0.1, then it's going to be E again, since we know that it starts with E, so then x1 is E plus E cos, so that's the differentiated function of 0.1. And then plus E, because we're going by 0.1, so the next one's going to be 0.2. So then that should correspond with C. I think that's right. This one I use cas again, but you just do, so that's going to be 1, 2, -1. It's going to be theta 3, 2. And that's going to be 1, 0, 1. So A plus, it doesn't really help to do the first one, but you're going to need it for later. So A plus B equals 1, 2A. Sorry, what I did, I just let A equals to this plus B. 2A plus 3B equals 0. Negative A plus 2B equals 1. I use the cas for simultaneous equations. So then, once I found those, I subbed it into here, and I found that this is going to be, I found that A 2B is equal to 7/2. So then if you sub that in, you should get is equal to 5. Yep. Find the magnitude of the component of the force F equals 1 that acts in that direction of 2, -3. So the 2, -3I, -6K, and F dot D, equals, you can use the cas again for this. I think it's on the vector to find the dot product. 108. So you just find the unit, and then you just find the dot product of the unit, and then it's going to be 92/7. That's B. 15. Two forces over FA equals to that. So first force is here, second force here. The mass is 3. Initially at rest, so U equals 0. At the position of this, so we know the initial position. So the Cartesian equation of the path. So the resultant is going to be those two forces added together, which is going to be FR equals 4 plus 2, 6, -3 J. No, plus 3 J. And that's going to be I. So then the Cartesian equation, we know that F net is going to be, so F net is going to, F net is going to be this. So A is going to be 6, 3 over M, which is 3, and that's going to be 2, 1. So then if we integrate that as an acceleration, we're trying to find the velocity. We integrate that, we'll get 2t and t. So then if we, that's the velocity one, and we're trying to find the displacement one. So if we integrate that and we know the original position is here, integrate that, it's going to be t squared I plus t squared over 2 j. That's going to be RT plus C. Since we know that when t equals 0, original displacement, position is I plus j, so then C equals I plus j. So then RT is equal to t squared plus 1 I, and then t squared over 2 plus 1 j, and then you can use your CAS, so you just equate x equals to t squared plus 1, and then y is equal to t squared over 2 plus 1. So, plus 1. So t squared equals x minus 1. And then you sub that into here, and you should get y is equal to x plus 1 over 2, which is E. Yes, E. 16. Let A equal to that, B equal to that. So A dot B is going to be AB cos theta. Cos theta angle first. So cos theta equals 1/9. So theta adjacent 9. So then sine theta is going to be 4√5/9. So then using the double angle sine 2 theta, it's just going to be 2 sine theta times cos theta. So 2 times sine theta, which is 4√5/9, times cos theta 1/9. That's going to be 8√5/81, which is D. 17. The acceleration when x equals to 2. So v is equal to dx over dt. I'm trying to find the acceleration. A equals v dv dx. We know v, so we can just sub this with this. So A is equal to v, so 1/x, times dv dx. So times by -1/x squared, which is -1/x cubed. We let x equals to 2. So it's just going to be -1/8. So then should be B. 18. Find the value of tan theta. So T cos, we resolute these, like whenever we get a question like this, we have to find the vertical and horizontal components. So T cos theta, it's in equilibrium. So this is going to equal to this, and this is going to equal to this. So T cos theta, so putting it like that, cos theta is tension is equal to F, and the vertical T sine theta is equal to mg. So then we do this one over this one. So T sine theta equals mg with mg over T cos theta A no, not theta, cos A equals F. So then we should get tan theta is equal to mg over F. So mg over F, this one E. Find the magnitude of change in momentum. So change in momentum is m change in v, or f change in t, but since we have these values, we don't consider this one. So the mass is 0.02, and the change, so moving with this, so the final is this one, so final minus initial, so 2 negative 7 minus 2 negative 10, and that should equal 0.02, wait, that should equal 0.06j, because that's going to cancel out. Negative 7, that's going to be 3, 2, yeah, should be this answer, which is B. An object has a mass of 2 suspended from a spring balance that is inside a lift traveling downwards. So it's traveling downwards. So F net resultant. So 30 newtons. So acceleration is going to equal to resultant over mass. Resultant is going to be 30 up minus mg down. So even if it's like a diagram, it's going to be like 30 up and weight force down. So weight force is going to be 2g over 2, and that should equal to 5.2 upwards, because this force is going to be greater than this. That's A. Find the distance in meters of the particle from the origin. So what we do is just find the mod, I guess. Yeah, the mod of x and y when t equals to pi by 6. So when t equals to pi by 6 for the x component, so x is going to be root 3, and y is going to be over 2. So then you find the mod of these two values. So over 2 squared, and that should equal to root 39 over 2 meters. And since it's from the origin, so x, it's going to be x minus 0, which is just x. So that's why I didn't really take that into, like, put it into here. Find dy dx in terms of t. So if it wants it in terms of t, we have to do chain rule. So dy dx is going to be dy dt divided by dx dt. And we know that dy dt is going to be dy dt negative 3 sine t, and then dx dt x, so 4 cos 2t. So then we make that over each other and we let t equals to pi. So therefore dy, so we let t equals to pi, but you already know that sine, since this is going to be on the top of the fraction, -3 sine of pi is just going to be 0, so dy dx is just going to be 0. Find the equation. Oops, I missed this. So we know that the gradient is 0 and t pi, and it's gonna be, so t pi is, that's gonna be 0 and that's gonna be 3, -3. So y2 minus y1 is just gonna be y equals to -3, and find the equation of the tangent to the curve. So that's the tangent. Find the velocity v in meters when particle. So we just diff that. So we know that r is going to be 2 sine something, I think sine 2t, 2 sine 2t, yep, and then cos, so 3 cos t j. Then diff this, it's going to be v is equal to 4 cos 2t I -3 sine tj, and we let t equals to pi, so that's going to cancel out, and 2 pi is just going to be 4, so v equals 4j, no, not j, I. Find the magnitude of the acceleration. So we know v, so we just diff that again, so double derivative of the displacement function. So it's going to be -8 sine I tj, and then that t equals to pi, so that's gonna cancel out pi, so mod of this is just gonna be 3, so then a equals to 3. On the t in seconds when the particle first passes through the origin. 0, 0 passes through the origin. So the x and y component equals to 0, so 2 sine 2t is equal to 0, and 3 cos t is equal to 0. So the only way that's going to equal to 0 is if it's like pi by 2. And if you sub that into there, you'll get like sine of pi, which is 0. So then you know it's right. Pi by 2. And this is first passes, so it's going to be positive. It's going to be like pi by 2 then the rest. Anyways, part D, express the distance d traveled as a definite integral, and find the distance So we use this formula like a to b root dy dt squared plus dx dt squared. And since we know it's like from t this to t this value, so we have to use this formula and not the other one, which is like ab1 plus dy dx. So we have to use this formula. Because he could ask you both, but yep. So 1/6 root. So we know dx dt. So 4 cos 2t squared plus -3 sine t squared dt. And I think this should equal to like 1.8 or something like that. Wait, let me check. Yeah, 1.804 meters, units. I said meters. I guess it's in meters. So, yep. 2. Express the relations. This one I just use CAS. You just like put this into here and put this into here, like using CAS to do it. So you should get x plus 2 plus I. If you do it by hand, you should get this. Squared. So then you should get plus squared equals. And then using CAS to simplify this, you should get y is equal to -x -5. So we're going to plot the function we just found. So -x -5. And u and v. So u we know is -2, -i. So 1, 2, -i. And -4, -3. So -4, 1, 2, 3. So here. And we know it passes through here and here. So should look like something like that. State the geometrical graph of this in relation to the points. Interpretation. So this is going to be perpendicular. That's the geometrical interpretation. These 2 points are going to be perpendicular to this line. So I guess the line is -x -5 is perpendicular. Oops. Perpendicular to the point U and V. U, V. Okay, sketch the ray of this. You can straight away like plot it, or you can either like do tan inverse pi over 4 equals to y, so minus, oops, what is u again? -2, -1, -2, -1, so plus 2, x plus 1, and then find that equation and put it onto here. Oh no, I just rubbed out the points. What was it again? -2, -1, -2, -1, -4, -1, 2, 3. Yep. So it's gonna be like around here, making a pi/4 with the horizontal. It's gonna go something like this. This is gonna be pi/4. You gotta make sure this is like open circled or something like that. Yeah. Write down the function that describes giving the rule. Oh, okay, so this is where we use it. So we can just 10 pi/4 is just 1. Minus I think this should be negative and this one should be negative as well. Yep. And then y is going to be, so this should be negative. So then this should be x plus 1. Yep. Okay, z minus zc with z. Zc is the center of the circle. Find zc in the form of a plus bi. So this lies on the circle. So zc minus 5i is equal to zc minus u. Oops. And this is going to be zc minus v. So then a squared plus b plus 5, because zc equals a plus b. Yep, a squared plus b plus 5 squared equals a plus 2, because minus 2 is plus 2 squared plus b plus 1 squared. And we know that, so they're going to be in the same point because they have the same r value. Yep. So a squared plus b plus 5 squared is equal to a plus 4. So we know that it's going to be u and v. They're going to lie on the points of the circle. B plus 3 squared. And then we just use CAS to simultaneously solve for a. So I got a equals to -5/3. B is equal to -10/3. So then the center is going to be -5/3, -10/3 I. So if we mod that, mod 25, yep. So R is going to be 5√2/3. Question 3a. Find an expression of f dash x. Let's say the coordinates of the stationary points. So you can just use CAS, put this in and then find the derivative. So f dash x, or you can just do chain rule, not chain rule, product rule. But that's going to take a long time. And you have your CAS, so. solve for that when it equals to 0 to find the stationary points. So just find f dash x is equal to 0. So this one equal to 0. So then you should get x equal to 0 and y is equal to 0. And then x equals to 2 and y is equal to 4 over e squared. And since it says state the coordinates, you have to like put it into this format, so 0, 0. Otherwise, I don't think you get the mark, even though you might have put this. 2, 4 over e squared. State the equation of the asymptotes. So the only asymptote that this has is just like, it's going to be like something like that. So y is equal to 0. This. So, which is y equal to 0. You can plot this graph because it's going to be difficult to draw. You can plot this graph like using CAS, and you should get something that so it goes through is this, and it goes up here, then down here. So, like that. I think it goes like that. And then that's going to be 2, 4 over e squared. Coordinates, or the point, so there's a point of inflection here and a point of inflection there. So 2 decimal places. 3, 8. 9. Okay. Find the double derivative of this. Again, you can use the CAS again, or you can just do it by hand, but it's going to take some time. So x n minus 2 e negative x minus n squared negative n. So equate this to 0. So you should get x equals to n plus or minus root n. And next part. So the point of inflections on the values of n is going to be 0 point of inflections. If there's 0, so you would want n to be 0, like, because these are like the point of inflections. So if there's going to be no point of inflection, so n is just going to be 0. And if you want 1 point of inflection, you're just going to have like 1 value. So just n is just going to be 1. And n values of n. So if you want 2 points of inflections, it has to be even, and if you want 3, it has to be odd. So greater than 2 or equal to 2, greater than equal to 3. Think. Yep. Wait, values of n. Yep. Question 4. Find the maximum speed. So we'll find the velocity the velocity like equation thing. So we just diff this. So negative 25 pi cos pi t over 6 pi plus 100 pi over 3 sine pi t over 6j. So that's equal to the v. And since we're finding speed, we mod this. So we mod this function. So that's going to be, you can just use a CAS for this again. Like, you're not expected to do this by hand. minus 7 over 9 cos squared pi t over 6. So then pi over 3, 1 minus 7 over 9 pi t. We do the, so 100 pi over 3 when cos of 0 is just going to be so then when it's going to be maximum, this is going to be 0, this is going to be 0, so then it's just going to be root 1 which is going to be 100 pi over 3. So then when cos pi t over 6 equals 0. So then you should get this as a maximum speed when t is gonna, when this is gonna be equal to 0, you find a t value when it equals to 0, and then sub that in to the equation, back into the equation, and you should get this as the max value for speed. So we know the original, so x is equal to 450 minus 150 sine pi t over 6. So x minus 450 over 150 equals sine pi t over 6. And then we know that y equals to 400. Oh, I should probably charge that. 6. So y equals to 400 minus 200 cos pi t. So y minus 400 over 200 and square this whole thing equals cos pi t over 6. And using using the Pythag one, sine squared t equal to 1. So you should get squared over 150 squared is 22500 plus y minus 400 over, so 200 squared, 40, 123 equals to 1. Okay, so we got to sketch this path. So we know it's going to be a circle, and what I did was just put this into the CAS. So it goes by 450 and 400. So that's 500, 450, and 400, 450, 400 here, and 150 sideways, and 200 up. So 200 up is here and here. Yep, and 150. Wait, did I put this in the right spot? Right here. And then 150 here and here. and then wait, no, not a circle. It's like the bent circle. I forgot what it's called. It's definitely not a circle. Yeah, it's called an ellipse. Yeah. It's definitely not a circle because these values are not the same. So the bottom bit is going to be 450, 200, and when t equals 0, so you can sub in into here when t equals 0 and t equals pi by 2. So t equals 0 and t equals pi by 2. So we know when t equals 0, that's going to be this value here, and when t equals pi by 2, it's going to be somewhere like this way. So it goes this way, clockwise. So 30t, let's sketch the path. So we do the same thing that we did before. So x equals to 30t, t equals x over 30, y is equal to t squared plus 40t. So then if you sub that into here, so y is equal to negative x squared over 900 plus 4x over 3. And if you plot that into a thing, Kaz, let me just take this out. It's going to look something like, so it ends here, 200, 1200, 0, and it goes through this point, so it's going to be like that. And yep. Yep. Label the points of intersection. So it's, the point of intersection is when you just equate them. So it's 600, 400. And it's going to be 316, 310. Determine whether the drone will, so if it's going to make contact, it's going to have the same position and at the same time, but they can have the same position and different time, but they won't like come into contact. So we just let 30t, so 30t, so we just let the x and the x of this function equate each other. So 30t equals 450, 150 sine pi t over 6. So then t is going to equate to 12.85. So negative t squared plus 40t equals 400 minus 200 cos pi t over 6. So t is going to equate 10 and t, or t is equal to 14.73. Since they don't have the same value of t, so as the drone and the airplane do not have the same position at the same time, they do not come into contact. So next question. I think this is the, yep. Okay, this one was a bit of a tricky one if you didn't understand it. So two objects, each with a mass of this, is connected by light insensible string that passes over a smooth pulley. So it's not rough. So no friction at point A, I guess. But there's going to be friction across F1 and opposing force. So there's going to be experiencing horizontal force opposing, so F1. So on the diagram, mark all the forces. So it's going to be, wait for this one, mg. There's going to be tension here. There's going to be, wait for this one, mg. There's going to be a force going this way. There's going to be tension here. And there's going to be normal, Fn. So the force is given by this. Show the expression for the acceleration. So mg minus f1 is equal to m. So 2m. They have the same mass. Yep, they have the same mass. So 2m times a. So F net equals mg minus F1. So then mg minus kmg, since we know F1 is here, equals to ma. So then we just solve a. So a's, I think you can just, for 2 marks, you can just put whatever they put here, because we know it's going to be correct. So g1 minus k over 2. So this system will only be in motion for certain values of k. Certain values of k, from the values of k system. So k is the constant for the. So the system will only be in motion for certain values of k. So a has to be, for it to be in motion, acceleration has to be greater than 0. So if acceleration is greater than 0, g, so then this value here, so g1 minus k over 2 has to be greater than 0. So then we'll get k, it's going to be smaller than 1. So k is going to be smaller than 1 but greater than 0. Part C, fine in terms of k, the time taken. So to reach point B, and B is midway between A and C. So B is here, A and C. So that's 5. So then we know the initial is going to be 0. We know the acceleration is g, it's already given. And we know that the displacement is going to be 5, so s equals to 5. So using SUVAT, s equals to ut plus half AT squared, and then we know that u equals 0, so that just cancels out. We sub in a into here. This is going to be complex, so you can use CAS just to solve for it. So I got t equals to t2 root 5 over g1 minus k. Yes. Express in terms of k when it reaches point B. So SUVAT again. So v squared equals u squared plus 2as equals 0. So v is equal to root 2 times a is already given to you. So g1 minus, whoops. The 2 on the bottom will just cancel out, so I can just write this whole thing again. And we know the displacement is 5, so then 5g 1 minus k. Yep. So then part E. So now we can't use SUVAT because it's going to change. It's going to be like a function. So we know that F2 is equal to this VB, the velocity at VB. So acceleration is going to be f2, so 0.075 g plus 0.4 v squared. So then we know that a equals half dv squared over dx. So half negative 0.4, 1.875 g1 plus v squared. And that's going to be negative 1 over 0.8 v. v squared. So negative 0.8 dx dv squared is equal to this. So if we want to integrate it, we have to have the same variable, so that's why I flipped it. No, wait, I have to flip this as well. 1 over 0.1875 g plus v squared. So then if we integrate this, it's going to be 0.8x is equal to log e 0.1875 g plus v squared plus c. Since we know when x equals to 0, v equals to 2.5, so we just sub that in, x and v into here, we should get c is equal to negative log e of 0.1875 g plus 2.5 squared. So then negative 0.8x is equal to log e 0.1875 g plus v squared divided by 0.1875 g plus 2.5 squared. So then, what are we finding again? Find the distance when it comes to rest. So when it comes to rest, v equals 0. So you just sub v equals 0 into here. And you should get x is equal to 1.85. And then we're trying to find from point C. So it's going to be like 5 or something. I'm pretty sure it's 5. So then 5 minus 1.85, which is 3.15 meters. And that's the last question.